Hey everybody, so I'm going to go ahead and videotape my lesson for the next day right now because I think this is kind of interesting. So once I stopped filming, I decided, well, what in the world is making the ice water and the room temperature water to both blow up, and it appears they're about the same size now after an additional 5 minutes. Well, when I measure them, they actually aren't the same size, but they're very close. The ice water is 6 3/4 inches, and the room temperature water is 7 3/4 inches, and now the one in the hot water is 16 inches. So this has changed remarkably since I was filming last. This is 4 1/4 inches more than when it was when I stopped filming. So I started getting curious about it. So I went ahead and I got my thermometer out, and I decided to take the temperature of each one of the bowls of water. So I decided the ice water was 6 degrees Celsius, and when you convert that, it's approximately 42 degrees Fahrenheit, 17 degrees Celsius, which is approximately 63 degrees Fahrenheit, and then the hot water is 32 degrees Celsius, or approximately 90 degrees Fahrenheit. So there is quite a difference between these, but there is a bigger difference between the room temperature and the hot water than it is between the ice water and the room temperature water. So these two are a little bit closer than this. So maybe that's one of the reasons why they're closer in circumference. But I was just curious to see, well, what are the actual temperatures? So the room temperature water was a little cooler than I thought it would be. I thought it would be at least 68 degrees, so it's a little cooler than I had expected. So I just wanted to check on that because that does affect, that's one thing that would affect our results. So that would be like a variable. So yesterday we found that when we add temperature to a solvent, that it does, in a gas form, it does affect the solubility. The gas, the carbon dioxide in here started to escape. And so the solvent started to let go of part of the solution. When it let go, then the gas started to escape. So the gas escapes when we add heat to a solvent that is a solution with a liquid and a gas. Now, with the ice water, even though some of the gas escaped, that happens just when you open the bottle of pop. When you open the bottle of pop, the fizz starts to come out. That's why you need to use a 2-liter bottle in a certain amount of time, or else the fizz leaves and it goes flat, and it's not very tasty then. So some of this is just natural, the carbon dioxide escaping when the cap is off. So again, solubility is a physical property that describes the ability of a solute to dissolve in a solvent to create a uniform solution. And we played around with the factor that affects it. We've played around with temperature. So hopefully you enjoyed this activity, and hopefully you see how the temperature did affect the solubility, because the gas does start to escape. And this is actually still bubbling. And this has been about 12-13 minutes. So there's bubbles there, but it's not bubbling up. And the Coke, there's nothing. It's not bubbling at all. So that's kind of interesting. If we add heat to the solvent, the gas in the solution, the liquid gas solution, begins to escape. All right? So I want you to finish your lab up and try this at home. See if you can try this out this weekend. Afterwards, as long as you clean the balloons, which I did before I used them, you can wipe off the outside here and you can still drink the pop. All right? So I want you to keep watching, keep thinking, always stay curious, and I'll see you next week.